All right, pre-calculus, chapter 2.5, day 3. So we're going to be using the Desmos graphing calculator website to graph and look and find zeros and max and mins and end behavior. And then we're going to follow through with algebraic solutions. And so I want you to go ahead and put in that x cubed plus x squared minus 8x minus 8 into Desmos, please. And, oops, I should have it here somewhere myself. So put the x cubed plus x squared minus 8x minus 8 into Desmos. And when you put it in, you're being asked, let's see, I'm going to do a split view. You're being asked to find all real zeros, relative max and mins. So I want you to get it so you can see the relative max and mins. So that right here, I would need to scoot up in order to see the relative max and mins. So if it's zoomed out, I'm not seeing everything. I mean, it's cubic, so I expect up to 3 places that it's crossing. I only see 1. And so if I zoom in too short, then that's not a good picture because I don't need it to be that big for the y-axis. I don't need it to be that wide for the x-axis. You want to get it so that you see the relative max and mins, which are here and here. Those are your relative max and mins. And in this case, that you see your zeros. So then over here, you can find all real zeros. It is the places it's crossing the x-axis. So you have a negative, and let's go to 3 decimal places, a negative 2.828, a negative 1, and a positive 2.828. For the relative max, I'm actually going to have you write the ordered pair. It's really a relative max of 4 when x is negative 2, but we'll accept the ordered pair because there could be, if it's to the 4th or 5th, you could have a couple of relative maxes, a couple of relative mins. So it's kind of good to know what x goes with that y. And then for the relative min, 1.333 and negative 14.519. End behavior, you should know it just by looking that this is x cubed, positive leading coefficient. We expect it to go like this. But you can also see graphically, as x goes to negative infinity, y is going down. Goes to positive infinity, y is going up to positive infinity. Now, over here, the x min max, the x scale, has to do with your graph. And what is the span of x's? I would say my min for my x is negative 6 and my max is positive 5. That's because if you have a different window, it distorts it differently and it looks different. And so that's why we put what is the x min and x max. Because you're going to sketch what you see in that little screenshot. And according to your window, it can look a little different. The x scale is what is the length of one box on the x-axis representing. And each box is going by 1 unit, so the x scale is 1. Each box is a length of 1 on the x-axis. The y min here, I have it at negative 24. And the max is, I can just say 5. It doesn't quite reach 6. And even on the y scale, my box length is going by 1. Questions on that? Questions at all? because my highlighter doesn't work on the Desmos graphing calculator part, only on my Notability. All right, so the idea is to sketch that on what you're seeing, what yours looks like, sketch it. And so I'm to the left 6, to the right 5, so just slightly to the right of middle. Okay, that's not exactly slightly. I'm trying to erase it. All right. And then the x-axis is quite a bit up higher. And so if I go 1, 2, 3, 4, -5, and 1, 2, 3, 4. It doesn't have to be perfect. Then I can get my zeros, which we said we're at -2.8, so somewhere around there, the -1, and the positive 2.8, somewhere around there. And then I can try to hit the maximum at -2.4. And then I can try and get the minimum, which is down, it's at 1 1/3, and down at -14.5. So -5, -10, -15. So 1 1/3 and down about 14. And then just have your polynomial go through. And the y-intercept is at -8 because that's your constant. So just to the best of your ability, try to scale it to what your min and max are for x and y and have it sketched. Just looking at Desmos. And then we're going to go to the algebraic solution. Algebraically, find the exact real zeros. And so we're going to set f of x equal to 0. And this factors by grouping. You don't want to have to always go directly to the rational root theorem. You want to go, can I factor it by grouping? And I can. If I take an x squared out and a -8 out, the binomials match. And so this factors by grouping. And so we get 0 is equal to the x squared minus 8 and the x plus 1. So we get x squared minus 8 equals 0, or x plus 1 equals 0. So x squared equals 8, or x equals -1. So x is plus or minus the square root of 8, which is plus or minus 2 root 2. And those are your x values. And if you would put 2 root 2 into your calculator and -2 root 2, those are going to equal where the values where you got your other x-intercepts off of Desmos. They're going to be the same. They're going to be the same. All right. Would you put the next equation in Desmos, please? X cubed minus 6x squared plus 7x. Error loading graphs. I guess I need to relog into Desmos. iPad is not connected to the internet. Oh no. I'm going to end the recording. At least there's one example, and that kind of is what you need to follow through with the rest.